Let me label that one here. 60. Doesn't matter which sections we pick, as long as that section is within this portion, these always apply. So the constant 60 everywhere in this section. And now we move on to the next one. So now what I want is to calculate what is the stress. No, what is the reaction in this portion. So the same thing, I pick up the cross sections here. So let me build up the right hand side, this portion. So that section will be something like this one here. So now copy the information. Here is 40. Here is 30.
45?
Yes. So 45. Thank you. What is the difference between the two free body diagrams? The difference is in this, the 75 is excluded because we select here. As long as we select the cross section not to over this point, then that will apply. And this force will be how much? 15? Will I be right? And 15, that means this 15 in this portion is going to squeeze to shorten. So that means that should be following our sign convention is 15 here. Here the number I write is only the magnitude, but for the sign you should memorize, you should kind of stick with the sign convention here, okay? Because later for each segment, some piece of the segment will be stretched, some piece of the segment will be shortened. So negative or positive sign in delta will be seen later. And now we move to, so we've done these sections. So the last one is working on this last piece here. So for the last piece, again, I pick up any cross sections. So that's cross section, let me show here. So this is 30. So by equilibrium, this is 30. And 30 is to stretch. So here it should be 30 here. To the end is 0. That be okay? And now we can proceed. For this segment, A, B, C, D. So let me label it. How about that? So this is point A, and this is point B, this is point C, and the end is point D. So for this segment here, that is delta, is D relative to C relative to D. So that means right now I'm working on the, for example, let me the first, second, and third. For the first segment, the deformation is this, and PL over EA, because in this segment, that is segment 1, everything will be will fit into our generic platform, right? And then we simply plug in the information, what is P? The P in this segment is given here 60, right? So 60, we work on the unit carefully. The 60 KIPS actually is 10 to the third thousand pounds. L, what is L? L is the length of the first piece. That is 12 inch. And E is the Young's modulus, 29 times 10 to the 6 PSI. PSI is pound per inch square. And A is the area. Area is this one. Who has a calculator? Punch that for me. 1.07 squared is 1.14 divided by 3.14.738. about 3.3 or 3.28. Come on, do you have a calculator?
For that area?
Huh?
For that area?
For this area?
Squared times pi divided by 4. I'm getting 0.0 or 0.899.
0.899. Oh, yes. Yes. How about just 0.9? Okay. So we work on this unit carefully. You can see the pounds appear, and in square, cancel it. So later on, the unit should be in inch. Okay, that's the one typical way when I do my exercise. My lecture notes here, all the labels are for all the solutions in the past. But right now, I'm kind of revising the content for the different numbers. So, but anyway, this is a traditional way I use in all my notes. Okay, just carefully work on. And then for this case, this is only give us our magnitude. So this is a magnitude. What is the attribute? What means is negative or positive? If we use stretching as a positive, what is this? This should be positive. So artificially, you put a positive to indicate, to remind yourself this is for stretching. This portion is stretching. Okay? So that's the first piece. Then the second piece. The second piece is, look at this one, B relative to C. So that is again P over EA. And for the second piece, we plug in the numbers. P is equal to 15 times 10 to the 3. L equal to 12. And now right now, let me skip over the unit. 29 times 10 to the 6. A is the same 0.9. So for this case, that would be the numbers. Whatever the numbers, let me pick up this one here.
So you don't take negative 15?
Yes, I'm going to write it. So here, again, this is negative. Why? Because for the second piece, the 15 going to compress. So that will correspond to the negative. Okay. So let me leave the numbers later. I will fill it up quickly for you. Okay, so let me leave it for a moment. For the third one, that is A relative to B. So that is PL over EA. So I can write it up quickly now. Would be equal to P will be, for the third segment, that is 30,000. L equal to 16. E 29. Come to the A. This one, 0.15, 0.225, divide, multiply 3.225, 68, 0.68 inch squared. I'm not sure about this number, okay? You have to punch. I use my mind to calculate that one. Whatever. How much?
Well, okay, so 0.618 squared times 4, 0.2999.
That's small.
0.3.
0.3?
No. Yep.
Okay. How come that's make that difference? No. Let me double check.
So you have your area equals pi over
Okay.
4 divided by.
Okay. I will figure out. Okay, that's right. Okay, this one is right. Okay, this number, and then this one should be positive. Okay, so in the result, so in the result, our result will be if anyone can help on the three figures, so therefore the deformation A relative to D will be equal to the three numbers. this number, I don't have the numbers here, but can I just use the symbols?
I have the numbers.
Okay, great. Great, thank you. If that's a mistake, what's your name? Thank you.
Yep.
Inch, so that would be equal to, I will give the final result.
Is that a 0 or a 6? Is it fixed to the
I
line?
have
It's a 0.
690, yeah. So that's 6, 0, 0.
And okay, so the net displacement at the D will be equal to that number. So for the same problems, the people might ask, what is the relative displacement between the 2 points B and C? The relative displacement between B and C, then that will be given by this number. Relative displacement between B and C. Okay? Any questions to this problem? And right now, the homework 2 homework hasn't been, the chapter 2 homework hasn't been available on Blackboard yet, but that will be available by this evening because I'm revising the certain content. And the way, again, from chapter 2 is this. For certain problems, you will give a limited attempt, just like chapter 1, until you get the right answer. You keep trying, just like you did in chapter 1. And then right after there's a 2 problems, I will give you a benchmark question. So that means the parameters of the benchmark problems will be the same from one attempt to another one until you get the right answer. And then once you have the right answer, you suppose have the right calculation procedures put aside. The next problem right after the benchmark problem will be the parametric. So that means I'm going to take 1 or 2 parameters, I'm going to change it from one attempt to another one. So suppose you can apply the calculation procedures to adopt this kind of the parametric change of problems. That'll be okay? Not every single problem. For this chapter, I only pick 2 questions. I try not to increase your workload, but try to give you a little bit challenge. Okay? So as long as you can work out the benchmark problems, you should be fine by repeating the same process. The same statement, but only a change could be, for example, I change 75 to 90, or 110, or 120. So basically, that's a programming that Blackboard will allow me to do it. Okay, to do it. Okay, so that is the. Any questions about this problem? Otherwise, I'm going to turn on the slides. Would you turn off the light? Yeah, sure. Thank you. So pretty much we have gone through a good amount of the content, and this actually is exactly the example we made. And the same concept, if you wish, you can refine the process and into a differential equation form. For this continuously change the model. Okay, simply you can do is this. For each piece, you assume the width, the dimension, or L is equal to dx. Okay, and then you repeat the same process as we did in our example, which only has 3 pieces. For this, you can put into infinite number of the pieces. And actually, if you still remember your calculus, probably Calc 1, you can put into right away into a differential equation. And that equation, we won't have any test or any homework, but that formulation will be equal to delta equal to PL over EA for each piece, that is an infinitesimal piece. And so that basically is for this case. And that one basically is P EA dx. And integration could be from 0 to the whole length. And furthermore, the force could be changed. That could be the function of the positions, which means the place from place to place. And E and A could be also changing from place to place. So basically that is the extension, exactly is the extension of our problem here. We only have 3 pieces, but here we put it into integral form. That means many number of the small pieces. Okay, and some people give me a kind of weird look. Okay, I will promise I will add one problem to this. How about that? No? Okay, so that is the major thing. And then follow up on coming Wednesday, I believe we can come up with a different type of a problem. We come to we call it compatibility static indeterminate problems. Okay, so probably today we just stop here. Okay, thank you.